Hi guys. Well, this is a response to a problem that Bryan posted well over a year ago. I'm sorry to say it's taken me this long to get to it, but I figured better late than never. So I'll put up a link to the original post in my response, and let's say I'm going to mess with the video editing and also throw up a picture of the original situation right here. So here it is. We have a 1966 Volkswagen Beetle suspended by two cables from a couple of pine trees. We also have a couple of reindeer towing the Volkswagen Beetle. And Bryan gives us that the distance between the two trees is 15 meters. The mass of the 66 Volkswagen Beetle is 840 kilograms and asks what the tension is on each of the two cables. So here we have a diagram of the situation, the two pine trees, the two cables, the suspended Volkswagen Beetle, the given mass, and we know the gravity is 9.81 meters per second squared. Also the couple of reindeer, though by their ethereal nature and their magical ability to fly, we're going to consider the reindeer in this situation to be massless. There's also one other piece of information that would make it much more reasonable to solve this problem, and that would be the angles between the cables and the trees. So I slapped a protractor onto the picture and measured roughly the two angles, and we're going to call this angle right here 32 degrees, and this angle right here 21 degrees. So what we're working on here is a statics problem, because this system at the moment is motionless, and the point in question is going to be right here. And because it's motionless, we know that the sum of the forces acting on that point must add up to 0. And we have three forces. The force in the right-hand cable, which I'll call F sub r. The force in the left-hand cable, which I'll call F sub L. And then downward, the force in that cable, which is equal to the weight of the Volkswagen Beetle. So let's calculate that right now. Weight, of course, is equal to mass times gravity, and we have 840 times 9.81. And I already worked these out, but I do still use the same HP 11C calculator that I was using when I taught you guys. These things are built like a tank, built like a 66 Volkswagen Beetle, and it just keeps on ticking. And 8240.4 newtons is the weight of the Volkswagen Beetle. Now that's easy, that's straight downward, but the cables are off in an angle, so we're going to have to break those forces into rectangular components. So we'll start with the cable on the right. Here's our 32-degree angle right here. And this force is F sub r times cosine of 32 degrees. And then there's an upward component, that's F sub r times the sine of 32 degrees. We'll do the same thing with our leftward cable. Here's our 21-degree angle right there. This is F sub L cosine of 21 degrees. And then we have an upward component, which is F sub L sine of 21 degrees. Now when you solve statics problems, It's simply a matter of setting the forces to the left equal to the forces to the right, the forces upward equal to the forces downward. So let's write a couple of expressions that do that for us. The upward forces, F sub L sine 21 and F sub R sine 32. And that is equal to the downward force, which is 8240.4. Then we'll simply set the force to the left equal to the force to the right. Okay? So the force to the right is F sub R cosine of 32. And that is equal to the force to the left, F sub L cosine of 21. And now we've created a situation in which we have two equations with two variables, and there are a whole bunch of methods you can use to solve those. I usually isolate one of the variables in one of the equations, dump the expression into the other equation, and then solve from that point. So let's do that. I'm going to solve for F sub R by dividing both sides by the cosine of 32. So F sub L cosine of 21 divided by cosine of 32. And now we have an expression for F sub R that we can stuff in to this equation up here. All right, so let's go ahead and do that. Here's the top equation coming down. F sub L sine 21 plus F sub R, which is now equal to this. So that's F sub R times sine of 32 equals 8240.4. Now we have an equation with just one variable and a bunch of numbers, because all these trig functions are just numbers. So we can isolate that F sub L and solve for it. So take a couple steps to distribute that out. F sub L sine 21 plus F sub L times the rest of this stuff. Cosine 21 sine 32 over cosine of 32 is equal to 8240.4. And now we can isolate the F sub L. F sub L times sine 21 plus cosine 21 sine 32 over cosine of 32. All right, brought that out, combined these terms, is 8240.4. And now we just divide both sides of the equation by this big mess here, and we'll have an expression for F sub L is equal to 8240.4 divided by sine 21 plus cosine 21 sine 32 over cosine 32. And now we can plug all that junk into the calculator and bring out the force on the left-hand cable, which turns out to be 8750.24 newtons. So there's our first answer. All right, that's the force, the tension in the left-hand cable. All right, F sub L. Now it's a real easy matter to take that solution and drop it back into this expression right here to solve for F sub R. So we have 8750.24 times the cosine of 21 divided by the cosine of 32. And when you chunk all that into the calculator, you come out with 9632.77. So there is the force in the right-hand cable, and that is the other answer that we're looking for. Now there is an easy way to check to give yourself some more assurance that you have the answer correct. If you were to plug those values in here, F sub L sine 21, you'd get 3135.81. And this one, right? F sub L sine 21, you get 3135.81. Take this one, the right-hand force, plug it in here, times sine 32, you get 5104.59. You add those two together, you better get 8240.4, and indeed you do. So, there you have it, the tension in the cables on the two pine trees. Of course, later on in our study of mechanics, we would get to the mechanics of waves, and we would look at the various properties of waves like frequency, amplitude, and wave harmonics. One of the best tools for studying those wave properties, of course, is the acoustic guitar, and that's always the context that I like to teach it in. So here is just a tiny piece of one of those lessons, just a little bit of an old Allman Brothers song called Little Martha. Hope this finds you all living happy, healthy, rich, and fulfilling lives. Take care.